Okay, so in this question we're given the equation of a circle. That's x squared plus y squared minus 10x plus 2y plus 22 equals 0. And we're also given the equation of a straight line. That's 4x plus y minus 2 equals 0. And we need to work out the shortest distance between the line and the circle. So in order to do this, we'll first visualize it. So we have a circle and we have a straight line. And the shortest distance between the circle and the line is this distance over here. So we need to somehow calculate this. And in order to do that, we're going to actually have to work out the center of the circle. That'll be the first step. And then we're going to construct the equation of the line that passes through the center and is perpendicular to the original line. And we'll call that coordinate A. And it turns out that we're not going to need to get the coordinate of this. We're simply going to get the distance between C and A and then subtract off the radius, and that should give us this distance here. So we'll first begin then by getting the center and radius of the circle. So we can first group up the x's and y's. So we get x squared minus 10x plus y squared plus 2y plus 22 equals 0. And we'll complete the square on each of the x's and y's. So we get x minus 5 all squared minus 5 squared, which is 25, plus y plus 1 all squared and minus 1 squared, which is a 1, and plus 22 equals 0. And then we get x minus 5 all squared plus y plus 1 all squared equals, and if we bring the 25, the 1 and the 22 over, we end up with 26 minus 22, which is positive 4. So therefore we've got the center, which will be 5 minus 1, and the radius will be square root 4, which is a 2. So we can put that in. So we've got the center of 5 minus 1, and we have a radius of 2. The next thing now, we need to work out the equation of this straight line. So we're going to use y equals mx plus c. We first need to work out the gradient of the original line. So let's work that out. So we can rearrange that to give us y equals minus 4x plus 2. So you minus the 4x and plus the 2. And therefore we've got a gradient of minus 4. So m1 is minus 4. That's that gradient there. Therefore the gradient of the line that we want, m2, will be the negative reciprocal. So that's positive 1/4. So we've got a point, 5 minus 1, and a gradient, positive quarter. We can do y equals mx plus c now. So we have y equals mx plus c. So therefore y equals 1/4 x plus c. And there's the point. There's our x and y coordinate. We can sub that in. So we have minus 1 equals 1/4 times 5 plus c, which equals 5/4 plus c. So therefore c equals, if we minus a 5/4 over, we get minus 9/4. So therefore the equation of the line that we want is y equals 1/4 x minus 9/4. So that's this line here, and we have the original line here, so we can now solve simultaneously to get this point A. So here's the original line and here's the perpendicular line. Since they're both equal to y, we can simply equate them and we can set the x's equal to each other. So we're going to get minus 4x plus 2. That's this one here, and that should equal this one over here. So that's equal to 1/4 x minus 9/4. And we can solve this. We can multiply everything by 4. So we'll times both sides by 4. So on the left we get minus 16x plus 8 equals, and this becomes an x, and that becomes a 9. So let's minus off the x and minus the 8 over, it's minus 17. And now we can divide by minus 17, we get x equals 1. And now we have a choice, we can sub 1 into either the original equation or the perpendicular one. We'll sub into this one. So we get, that's minus 4x plus 2. So y will equal minus 4x plus 2. And that's minus 2. So we have a coordinate now, 1 minus 2. And that's the coordinate of A. And now that we've got that, we're now ready to get this big distance, the distance CA. So we'll do it over here. So therefore, the length CA, and we can use the distance formula. So it's 5 minus 1 all squared. That's 5 minus 1. Plus, and it's a minus 1 and a minus minus 2. All squared and then rooted. So that equals, that's 4 squared is a 16. And this is 1 squared, which is a 1 all rooted. So that equals root 17. So we now have that the big distance here is root 17. And we know that the radius is 2. Therefore, the distance that we're looking for should be root 17 minus 2. So therefore, the final answer, therefore, is root 17 minus 2.